Bismillahirrahmanirrahim. Dear students of 10C, Assalamu alaikum. I am your teacher Muhammad Ilyas, and this is our 8th interaction regarding chemistry for Cambridge. Dear students, our today's topic is the reactivity series. And this is from your book chapter number 12, and according to CIE syllabus, topic number 9.2 and subtopic A to B. Our objectives for today's session are as follows. We will be able to understand the place of metals in order of reactivity. The metals which we are going to consider are as follows: aluminium, calcium, copper, hydrogen, iron, lead, magnesium, potassium, silver, sodium, and zinc. These metals will be placed in order of reactivity by reference to their reactions of these metals with water, oxygen, steam, and dilute hydrochloric acid. Secondly, the reduction of their oxides by carbon and or by hydrogen. The reactivity series as related to their tendency of metals to form its positive ion, illustrated by its reaction with the aqueous ions of the other listed metals and the oxides of the other listed metals. So these are our objectives for today. Dear students, now we are moving towards the definition of reactivity. The reactivity describes how likely an element is to form bonds with other elements, and this is because of an valence electrons in the element. Means that how many electrons are present in the outermost shell of the element. This determines the reactivity of the element. This is the reactivity series. Dear students, a number of metals like gold, silver, copper, and iron, which have been known and used since ancient times. Other metals like sodium, potassium, and aluminium were only discovered when electricity became available. Why is electricity needed to obtain some metals from their ores but not others? To answer this question, it is necessary to consider the different reactivity of metals, as you can see. The reactivity series from bottom to top, when we move from bottom to top, the metals become more reactive. At the bottom, least reactive, and at the top, most reactive metals are present. And the reactivities of metals is described as how easily an atom loses an electron. For instance, potassium is extremely reactive because it has only one valence electron, so it is very easy to lose it, forming a positive ion, whereas on the other hand, copper is a weakly reactive metal because it has more valence electrons, so it is harder for it to become a positive ion. Now we are going to consider the reaction of the metals with oxygen. Dear students, potassium and sodium burns to form both oxides and peroxides, while calcium, magnesium, aluminium, zinc, and iron burns with decreasing vigor to form oxides, while copper, and lead and copper does not burn but form surface layer of oxides, while silver and gold, they don't show any reaction with the oxygen. So you can see from this slide the metals in the top of the reactivity series are much reactive with the oxygen than the metals which are at the bottom of the reactivity series. Now we consider the reaction of the metals with water. Dear students, potassium reacts very vigorously to form potassium hydroxide and hydrogen gas with the cold water. Enough heat is produced to cause hydrogen gas to catch fire and explode. While sodium also reacts very violently to form sodium hydroxide and hydrogen gas. Hydrogen gas may catch fire and explode. Calcium reacts readily to form calcium hydroxide and hydrogen gas with the cold water. Dear students, magnesium reacts very slowly with the cold water to form magnesium hydroxide and hydrogen gas. A test tube of hydrogen gas is produced only after a few days. While magnesium reacts violently with the steam to form magnesium oxide and hydrogen gas. A bright white glow is produced during this reaction. Dear students, zinc don't show any reaction with the cold water, but it reacts with the steam to produce zinc oxide and hydrogen gas. Iron also don't show any reaction with the cold water, but hot iron reacts slowly with the steam to form iron oxide and hydrogen gas, while lead, copper, silver and gold don't show any reaction with water or steam. Now we are going to consider the reaction of metals with dilute acids. Potassium reacts explosively, and these reactions should not be carried out in the school laboratory. Sodium also show very explosive reaction with the dilute acids. Dear students, calcium reacts violently to give hydrogen gas. Magnesium reacts rapidly to give hydrogen gas, while zinc reacts moderately fast to give hydrogen gas, and iron reacts slowly to give hydrogen gas. As you can see that when we move from top to bottom, the reactivity of the metals with the dilute acid decreases, while lead, copper and silver shows almost no reaction with the acids. Dear student, this is the summary of the reactions of metals with oxygen, with water and with the acid. You to understand these reactions. Now we are moving with the reaction of the metal oxides with the carbon. First of all, we are going to see that carbon can remove oxygen from the oxides of metals that are not too high up in the reactivity series. The lower the position of a metal in the reactivity series, the easier it is for carbon to remove oxygen from the metal oxide. So you can see the carbon which is going to remove the oxygen from the oxide of metals, that is only going to remove the oxygen of the oxides of metals which are below the carbon in the reactivity series. Here are some examples. Dear students, you can see from the slides the potassium oxide, sodium oxide, calcium oxide and magnesium oxides are not reduced by the carbon, while the zinc oxide, iron oxide, lead oxide, copper oxide are reduced by the carbon. Silver oxide reduced by heating only.